Okay, I did tell you that this was going to be on co-ratios, but as I ended the last video, I looked at this and went, oh no, this could totally be simplified further. So I just wanted to finish this sum because it didn't feel right. Okay, so if you look at this, it's sort of bugging me that, yeah, with this cos squared x, you can kind of remember that we had equals 1, right? So cos squared is the same as if you take the sine x over, it becomes 1 minus sine squared x, right? So that is kind of very similar looking to what's going on at the top. So check what happens when I do this. Okay, and by the way, this is negative cos squared. So it's going to be negative of whatever you replace it with, which is 1 minus sine squared x. Now, I want you to kind of stop and think about what kind of factorizing you think this is. Because I think to me that looks like difference of two squares. 1 is a perfect square. Sine squared is a perfect square because remember anything with an even power is a perfect square. And there's a minus sign. So, yeah. 1 minus sine x over negative. Then remember difference of two squares, you make two brackets. So this is 1 plus sine x and 1 minus sine x. Okay, now this looks like something you can simplify. Because if I put this top one in a bracket, I can just cancel that whole top with that whole bottom. There's a negative at the bottom, so I know this whole thing is negative. The top disappeared, so it becomes 1 over 1 plus sine x. Okay, now that looks like it can't be simplified further. Okay, so what today's video is actually about is co-ratios, which is a very, very similar process to what we did with this. Remember with this we asked ourselves where, and then we changed it to a positive or negative, okay? Now you've, oops, oh no, let me just check that that's still in the shot. Yeah, we're good. Okay, so it's going to be a combination. So for this, you're still going to have to use these things over here. But when it comes to co-ratios, and co-ratios is anything to do with 90 plus or 90 minus, okay? Here is a list of what you can replace it with. YouTube has plenty of videos of explanation of where this comes from. The basic idea is that if you have a triangle, and this is a right angle triangle, let's say for example this is 30 and that's 60, okay? That's opposite, hypotenuse and adjacent to the 30. So if I said sine 30, it would be that one, okay? So let's just call this P, Q and R, sorry, it's getting messy. Opposite would be P over hypotenuse, which would be R. But if you look at it from the 60 point of view, right? This is now adjacent and that's now opposite. So let's say for example I wanted cos of 60. It would be adjacent, which is now P, over hypotenuse, which is R. So as you can see, sine of 30 is the same as cos of 60. They have the exact same ratios, and if you add them up, it is 90. So that's a basic idea of where these things come from, but you can go and have a look at some other videos on YouTube if you want to. Okay, so now again, it's just a case of replacing. It's so simple. So the 2 just chills there. We're not going to do anything about that. Because we now need to decide if it's going to be positive or negative, and then you're going to remove that 90. So if I look at cos 90 minus, where's cos 90 minus? Yeah, it's cos 90 minus. Cos 90 minus makes it a positive sign. So now instead of writing cos 90 minus, I'm now going to write sine x. Okay. Now just bear in mind this is already a minus, so if your sign is going to change to a minus, you need to make sure that you change this to a plus, because 2 minuses will make a plus. Okay, sine 360 minus. 360 minus is in the fourth quadrant. Now you follow your old little system that I gave you. So fourth quadrant means that sign is negative because this is a cos. Now remember I told you it was a negative. Now you've got another negative, so this needs to be a positive. So it becomes positive sine of x. Remember with these ones, it doesn't change. So sine won't change to cos. With co-ratios, they change. So for example, this was cos. Now we change it to sine based on what they've given us. So it's a bit different. With this one, the actual, it actually changes. With this, it's just the sine. Okay, all over. Now we go over here, sine 90 minus. So let's look for a sine 90 minus. There's a sine 90 minus. So it stays positive and it becomes a cos positive. So this now becomes 2 cos of x. Okay. Now this over here is cos 180 plus x. So remember now it's just the sign that changes. This is the old stuff. 180 plus x is here in the third quadrant. Cos is negative in the third quadrant. But it already had a negative sign. So 2 negatives will now make a positive. So this becomes positive cos x. Okay. Now these are like terms. Can you see at the top here they're like terms. 2 sine x plus sine x is 3 sine x. Alright? The bottom, 2 cos x plus cos x is 3 cos x. Do you recognize this? That is tan. Sine over cos is tan. 3 over 3 is 1. So this just becomes 1 tan or tan x. Don't you just love how these things simplify so nicely? Okay. This one over here. Again, remember when you have squared, your answer just becomes squared. So don't get concerned because you see a square. So here we're looking for 90 minus, cos 90 minus. Here is cos 90 minus. So instead of writing cos 90 minus, we're now going to write sine. So this is going to become sine squared x. Okay, positive because it shows us here that it's positive. And the square, don't forget. Okay, now just be careful, you have a negative sign here, so whatever it changes to, you must take that into account. This is sine 90 plus x. Where is sine 90 plus x? Here. So it becomes a positive cos. And a positive and a negative, it will remain a negative. So this becomes negative cos x. Okay, all over. Tan 180 plus is like the old stuff. 180 plus tan is positive. So this just becomes tan x times sine 90 plus. So now we go back. Sine 90 plus is just positive cos. Cos x. Okay, so learning curve, because I'm looking at this and thinking I could simplify this, but I'm trying to decide how. I know the bottom we can do. So sine squared x minus cos x. Okay, all over tan will become sine x over cos x, and we're timesing it by a cos x, so we can cancel it, and you're just left with sine x. So this is now sine squared x times minus cos x all over sine x. Okay, and now you can see that this sign will cancel with one of those signs. So at the top, and by the way, this negative in the middle, it's a positive times a negative, so this is just a negative the whole thing, and it's sine x cos x. I just wanted you to take note of the fact that when I got here, I knew it could be simplified, but at the top, honestly, I was wondering, I was like, should I replace the sine squared x with 1 minus cos squared x? Would it become a trinomial? There are always different ways that things can happen. I don't think that would have worked here, but the point is it can seem confusing which route to take. So just take a route, and if you are wrong, go back to the start and try again. I think, yeah, that's all for this video.